One of the ways to understand polynomials is to understand how we classify them. Now we know that polynomials include coefficients and variables. So let's look at the example of 3. If we look at that example, we could say that it has a coefficient of 3 and a variable of x to the 0, because we know that 3 times 1 is the same as 3. So we call this one a constant. And the degree, or n, means the exponent. So our exponent here is 0. Let's look at when the exponent equals 1. So an example could be 5x or 5x plus 4. We call this type with degree of 1 linear. And we know that because if x is any other number on a graph, it would actually plot a line. So 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. All those points, we could plot them on a line, and that's what they would be. So that's linear. Now what happens if the exponent is 2, as in the example of 2x squared plus 3x minus 2? We call this one a quadratic. And I spelled quadratic wrong. So let's correct that. Quadratic. There we go. And with a quadratic, they look like a parabola. And you'll have equal points on either side. If we look at the example of exponent 3, as in the example of 5x cubed plus 3x squared minus x plus 9. We call these cubic. Like a lot of things with 3, cubes, cubic. And these ones sort of look like that. So they have a little inflection point on them if you look at a graph. Let's look at ones that look like 4. So an example would be 3x to the 4th minus 2x cubed plus 8x squared minus 6x plus 5. We're getting really long in these. And these we call quartic. I know it's a little bit of a different word than a lot of you are used to hearing, but the word is quartic. And these ones look like this. So they have a slight bump, and then, so they look like almost like a big parabola with a slight bump in it. And the bump could be even a little bit bigger, right? Could be like that. And then what happens if it's a 5 and is 5? So as in the example of minus 2x to the 5 plus 3x4 minus x cubed minus 2x plus 6. These ones we call quintic. And with quintic, again, because cubic are this way, kind of look like a wave. The quintic, because this is negative, so this one's going to flow down. So these ones will have a couple other inflection points on them. So they just look a little more wavy than you would see in the other ones. Whoops. So when we're naming polynomials, we're looking at the highest exponent. And that determines the name of the polynomial.